In this video, I'm going to go over 4 examples of how to solve linear equations. Before I go into the examples, you need to know these definitions. We've talked about them in class, but in case you've forgotten, please pause the video and go over them on your own. Once you're ready, hit play to move on. In class, we talked about the different techniques we need to use in order to solve equations. The 5 steps are listed to the side. I'm going to use these 5 steps to solve this example. Step 1 says to get rid of fractions by multiplying a common denominator. In this example, I don't have any fractions, so I don't really need to worry about step 1. I can skip over to step 2. Step 2 says if you have brackets, distribute the coefficient. Coefficient, remember, means the number in front of the bracket. So I've got 2 brackets here and here. So I'm going to need to distribute the number in front. Remember, the distribution is only for the numbers inside of the brackets. Pay attention to whether the coefficient is positive or negative. In our second bracket, we have a -2 in front of those brackets. So when I distribute, that -4 inside the bracket becomes a +8 because -2 times -4 is +8. So I don't have any fractions. I've distributed so that I don't have any brackets. My next step is to collect like terms on either side of the equation. On the left side of the equation, I don't have any more x's other than the 4x in the front, but I can simplify 8 minus 9. On the right side of the equation, I have a 3x and a -2x. Those are like terms. I can combine them, and the 8 is left on its own. So the next line of my equation looks like this. So step 3 is also completed. Next, it says to use zero sums. So first, I check to see if there's an x on both sides of the equation, and there is. There's 4x on one side of the equation and 1x on the other side of the equation. So I'm going to cancel the smallest x. The smallest x in this case is 1. So remember, what you do to one side of the equation, you have to do to the other side. So I'm going to subtract x from both sides of the equation. 4x minus x gives me 3x's. And on the other side, x minus x, that just cancels out. I'm just left with a +8 on the other side. Next, I use zero sums to cancel any numbers that are adding or subtracting x. On the left side, I have a -1, so I'm going to do a zero sum here, right? Do the opposite. I'm going to add 1 to both sides so that that cancels out, leaving me a 3x on the left and 9 on the right. So zero sums, step 4, also completed. The last step is to divide or multiply any numbers that are multiplying or dividing x, meaning do the opposite. Here I have a 3 times x equals 9. To cancel the 3, I'm going to do the opposite. I'm going to divide by 3 instead of multiplying by 3. 3 divided by 3 is 1, so I'm left with an x on the left and a 3 on the right, and I have solved my linear equation. For my second example, I'm going to throw in some fractions. Now I do need to get rid of a fraction. So step 1 is to multiply by a common denominator. Here, I only have one fraction. The denominator is 4. So in order to get rid of that denominator, I'm going to multiply every term in my equation by 4. This will help me get rid of that denominator. Don't forget that when we are multiplying fractions, 4 times 3 over 4, we can make the 4 a fraction by putting it over a 1. We can cross reduce. 4 goes into 4 one time. This is going to give me 3 over 1, or just 3. So my new line looks like 3x plus 8 equals 24x minus 16. So step 1 is completed. I've gotten rid of any fractions that I had. I move on to number 2. If you have brackets, distribute. I don't have any brackets, so I can go ahead and skip number 2. Then it says collect like terms on either side of the equation. Well, the left side and the right side don't have any common terms or like terms, so I can skip number 3 in this case also. I move on to zero sums. First, I cancel the smallest x. Well, the left side has 3x, the right side has 24x, so I'm going to cancel the smaller one. Then I move on to canceling numbers that are adding or subtracting the x. So this means I'm going to add 16 so that it gets canceled on that right side. And now I'm done with my zero sums. Last step is to, again, divide anything that is multiplying the x. Right now I have a 21 multiplying the x, so I divide by 21 on both sides. And this gives me that x is 24 over 21. However, that is not my final answer. Anytime we have fractions, we check to see if we can reduce. In this case, I can divide top and bottom by 3 to give me that x is 8 over 7. For example 3, I'm going to add in some brackets and some fractions. Going through my rules for solving, I first need to get rid of the denominators. In this case, I have 2 denominators. I've got a 5 and a 3. Which means my lowest common multiple is 15. So to get rid of my denominators, I'm going to multiply each term by 15. Remember that when we have brackets, the whole bracket is considered one term. So I'm just multiplying the number out front. So this is what the equation should look like if you did that correctly. Again, remember, when we are multiplying a number by a fraction, we can make the number a fraction by putting it over a 1. We cross-reduce. 5 and 15 have a 5 in common, so I can divide both of them by 5. That reduces to a 3 and a 1. So this is 6 over 1, which is just a 6. That's how I got my first coefficient there. And I did the same for all the others. All right, so denominator's gone. I am moving on to brackets. I do have a bracket, so step 2 is that I need to distribute the 5. Distribution done. I then need to look at collecting terms. On the left side, I have 6x's and negative 45x's. I can combine those. On the other side, I don't have any like terms. Collecting like terms is done. I then move on to zero sums. Now, normally I say to cancel the smallest x first. In this case, the smaller x is negative 39 because 39 is negative, 5 is positive. Positive is always bigger than negative. But the left side of my equation already only has x's. The right side of my equation has x's and a number. So it would actually be easier if I move all the x's to the left, since there's no other numbers there. So I'm going to cancel out my 5 by subtracting 5 from both sides. Now I don't have anything else other than x's on the left and just numbers on the right. So that means my zero sums are done. I then go to the last step, which is to get rid of anything that's multiplying or dividing the x. I have a negative 44 multiplying that x. So to get rid of it, I'm going to divide by negative 44 on both sides of the equation. So the 44's cancel on the left, leaving me with an x. On the other side, I'm going to have negative 20 over 44, but I can reduce that by 4 to give me that this is going to be negative 5 over 11 as my final answer. In my last example, I'm going to use an equation that has a bit of an ugly fraction or fractions in it. Previously, we talked about how to deal with fractions where the numerator or the denominator is not just a single number. Anytime we have a fraction where one of the top or the bottom, or maybe even both, is not just a single number, we have to treat them as one thing. So in this case, my numerator, 3x plus 5 on the left and 2x minus 1 on the right, are single terms. And so we got to make sure that whatever we do with this equation, they have to stay together. So the way that we're going to do that is we're going to add invisible brackets to the tops of these equations, just to remind ourselves that those are one thing and they have to be together because they are the numerator of those fractions. I then go forth and I will do all the steps that I've been doing just as I have done before. So step 1 is to get rid of the denominators. I have a 6 and a 5 in the denominator. My lowest common multiple is a 30. So I'm going to multiply both sides by 30. You'll notice that in my next line, it looks like I just moved this denominator up to the top of that, and this denominator to the top of that. This is what we call cross multiplying. It's a little bit of a shortcut that we use, but it only works if there's a single fraction on the left and a single fraction on the right. No other terms are adding or subtracting or anything else. So if you have a fraction on either side of the equal sign, instead of finding the lowest common denominator and then simplifying, you could take the denominator of the right and put it as the coefficient of the numerator on the left. You could take the denominator on the left and use it as a coefficient for the numerator on the right. If you're not sure or you're a little confused of how that worked out, that's okay. This is just a shortcut that we use. If you use the multiplying by the common multiple method, it's always going to give you the right answer. So there's just a little bit of a shortcut there. So we multiplied both sides by 30. We ended up with 5, 3x plus 5, and 6, 2x minus 1 as either sides of the equation. So step 1, get rid of fractions, done. Step 2, if you have brackets, distribute. So I'm going to take my coefficient and I'm going to distribute inside of the brackets. Distribution is done. I then check to see if I can collect like terms. It doesn't look like it, so I can skip over step 3. I then go into zero sums. So I'm going to cancel the smallest x. In this case, it is the 12. So subtracting 12 from both sides of the equation. I then need to get rid of that 25. So I'm going to subtract 25 from both sides. So step 4 is done. Lastly, I divide by anything that's multiplying my x. So to get rid of the 3 times the x, I will divide on both sides, checking to see if I can reduce. I don't believe I can here. So my final answer is that x is negative 31 over 3. And that is everything we did in chapter 4.